Molecular geometry. Molecules are three-dimensional objects. Their shapes affect their properties. In order to determine the shape of a molecule, we use the valence shell electron pair repulsion theory, or VSEPR. According to this theory, the molecules will adopt a shape geometry that will reduce the repulsion between the bonded electrons. The electrons want to be as far apart as possible, and you can click here for the pretty decent simulation on this. VSEPR theory assigns a three-digit code to each molecular shape. To determine this code, we must first sketch the Lewis structure. So here's our three-digit codes, and then depending on the code, that tells you what the shape of the molecule is. The first digit of the VSEPR number is the total number of electron domains around the central atom. The electron domains around the other atoms are not included. This means the total number of bonds and lone pairs. Double and triple bonds only count as one electron domain. So here's an exercise. Circle and count the relative domains for each of the below. Take a few seconds, pause the video if you need, and the answer will be on the next slide. Here's the answers. The first digit is the total number of electron domains around the central atom. You don't include the other atoms. So we need the total number of bonds and lone pairs. So let's look at the first one. There's 1, 2, 3 bonds. Now you look at all these lone pairs, but they don't count. They're not on boron, so the number is 3. Next one we have xenon, 1, 2, 3, 4 bonds. And then we have 2 lone pairs around xenon, the central atom, that's 6. And then over here with the 3 oxygens, here's our center atom here. It has 1 bond, 2 bond, and 1 lone pair. So that's going to be a 3. You don't count these. Those are not the central atom. The first number gives you the Electron-Domain Geometry, EDG, the shape of the molecule including all bonds and lone pairs. 2 atoms, or an atom and a lone pair around the central one, will form a linear shape with bond angles of 180. Right, that angle there is 180. 3 atoms and/or lone pairs around the central one will form a trigonal planar shape with bond angles of 120 degrees. These are all 120 degrees. If you have 4 atoms or lone pairs and/or around the central one, you have a tetrahedral shape with bond angles of 109.5 degrees. Looks like a little pyramid there, doesn't it? 5 atoms and/or lone pairs around the central one will form a trigonal bipyramidal shape with bond angles of 120 degrees and 90 degrees. 6 atoms and/or lone pairs around a central one will form an octahedral shape with bond angles of 90 degrees. A whole bunch of right angles over there.